Okay. Hello guys. Good evening. There's some fluctuation in the internet. I think that's why I'm just going in and out. Okay. I think now it's fine, I guess. Are you guys able to hear me? Fine. Is it fine?
Yes, sir.
Yes, sir.
Okay. Fine. So we'll just start. Okay. Just give me a moment. Let's download it. Where is it? What is wrong? Ah, yes. Why is it not uploaded? Oh my god. रोटी और दाल बनाओगे? Okay, now we are good to go. No, let me share my screen. I guess it took a little time. There are some issues. Right. Okay. Right. So next, first question: the hardness of water is caused by MgHCO3 twice, CaCl2, and CaSO4. All of these, any calcium and magnesium salts will be able to do this, except for carbonates, right? Except for CO3 minus, right? Other than that, all anions of magnesium and calcium will form your, will cause hardness. Okay, carbon exists in the atmosphere in the form of what? In the form of obviously carbon dioxide only.
Carbon dioxide.
Yeah, only carbon dioxide. Carbon monoxide is not available in the nature. It's because of fast pollution, it is there in the atmosphere. Please understand that. Okay, carbon monoxide is a pollutant. We are creating it. Okay, right. Next, what is the correct nomenclature of this? Now it's very simple. Now you have to start numbering from here because this methyl group has to get the least possible number. So it should be 1, 2, 3, and 4. So, so if it's 4, it should be butane, right? And the third position, we have a methyl group. So it should be what? 3-methyl butane. 3-methyl butane, right? Next, let me make it a little bigger. Okay. Next, the formula of an ester from which an acid and alcohol is formed as follows. Name the acid and the alcohol. Now it's very simple, guys. Whenever you are going to have this RC double bond O R dash, R can be anything. R can be any number of carbon atoms. Okay. Now this is what is called as ester, right? The moment you see this C double bond O and O together is what is your ester, right? And whenever you want to know what is the acid and what is this thing, you break this C single bond O. You break this. Okay, and this side you add OH and this side you add H. Basically, when you go hydrolysis, when you add H2O to this, H and OH are there, right? To the oxygen side you add O, to the oxygen side you add H, to the carbon side you add OH, right? So now what are you going to get? You are going to get R, C, double bond O and OH, that is this part, right? And this part is now going to become what? R dash OH. That same thing we'll do here. This is your CO single bond. We'll break it and put H and sorry, OH and H. This is OH and this is H. So we will get CHOH. That is nothing but HCOOH, and that is nothing but your what? Formic acid. Or it is also called as what? It is also called as methanoic acid. Right? And what is the other one? The other one is going to be CH3, CH2, CH2OH. Right? Is it not CH3, CH2OH? That is nothing but your 3 carbon atom with alcohol. Right? So formic acid and propanol. Where is it? Option D will be the answer. Right? Next. Carbon forms 4 covalent bonds by sharing its 4 electrons with univalent atoms, for example, hydrogen. After the formation of 4 bonds, complementary electronic configuration of that very simple. So we are going to have 2,4 before bonding. Now it is going to become 2,8 after bonding. That is obviously going to be helium is going to have 2. Neon is going to have 2,8. So it is going to attain a configuration of neon. Right. Next, when acetic acid reacts with ethyl alcohol, when acetic acid reacts with ethyl alcohol, we add concentrated H2SO4. Now that's very simple, guys. It's exactly opposite of your I don't know, your reverse of esterification. This is esterification reaction. We have ROH, right? And we'll write C double bond OH with R dash, right? Now I will be going for some dilute, concentrated H2SO4. Now, what is the role of this? Is just to remove this water molecule, OH and H.
It's
and
a dehydrating agent, sir.
Obviously, right? This is going to act as a dehydrating agent. Okay, right? The process is called as esterification. This reaction is what is called as esterification reaction, and dilute H2SO4 act as your what? Dehydrating agent. Right? So dehydrating agent and esterification acts as dehydrating agent, and the process is called as what? Esterification. So option D will be the answer. Next. If 20 coulomb, okay, this is physics. Physics. So physics. This is also physics. This is physics. This is biology. This is also biology, right? No. List any 2 tests experimentally distinguishing between an alcohol and carboxylic acid and describe how these tests are performed. Now it's very simple. When I have alcohols are not that acidic, whereas your carboxylic acids are acidic. Is it not? So when I make it react with, say, for example, NaHCO3, which is a weak base, right? No reaction would happen. But in this case, if you make it react with NaHCO3, you are going to form what? RCOO minus Na plus. We are going to form H2O, as well as carbon dioxide gas will be evolved, because normal acid plus bicarbonates, how it is going to react?
Sir,
Salt plus.
Is it enough if we write effervescence is produced?
Effervescence produced in what? When you do what?
With the carboxylic acid.
Making it react with what? You're going to produce
carboxylic acid.
What? Carboxylic acid with what?
Sodium hydrogen carbonate.
No, we cannot say effervescence. You can say that this carbon dioxide will be released and this will be able to turn your lime water milky. That you can say.
Okay.
Yes. That you can say. But in this case, no carbon dioxide, and that gas evolved is not going to, turn the lime water milky. Right? That is how you'll be able to go further. Okay. Next. Okay. An organic compound A is constituent of many medicines used as antifreeze and has a molecular formula of C2H6O. Upon reaction with oxidation another compound V, this and all, you don't have it in syllabus, right? Do you have oxidation reactions in organic chemistry?
Yes, sir.
Have you seen this reaction? Say if I have
Yes, sir.
Yes, sir, we have, sir.
OH, okay, you have. Okay, that's amazing, right?
Potassium
Now you're seeing,
permanganate and potassium dichromate, we have both. So.
that's good, that's good, right? So this is used in antifreeze. Here only we'll be able to say that this ethanol, right? This ethanol is going to react with KMNO4 to get oxidized. Now this CH2OH part is entirely going to convert it into COOH. That is how you're going to get C2H4O2. That's it. Now write the chemical equation. This is the chemical equation. That's it. This is A and this is your B. Right? Okay, next. Okay, I will click on cost of seeing TV. Red color, okay. Right, a short on biological significance, homologous series. Okay, now what is homologous series? Homologous series are the same class of compounds, varying.
They have
by
the same
what?
functional group.
Varying by one CH2 group. Okay, for example, CH2CH3 and CH3CH2CH3 are part of same homologous series because only difference is what? CH2 is changing. Okay, write any two characteristics of homologous series. Obviously, they will have different number of carbons, right? And they will have different boiling points also. Same members of homologous series will have different boiling points. Okay, and they will have different number of carbon atoms. Their molecular mass will be different. Like that, will be able to speak. Okay, next. Why carbon and its compounds are used as fuels in most cases? Now it's because they will easily undergo combustion. Right? For example, if I take, a LPG gas, I don't know whether you have seen it. In the LPG cylinder, they have written butane and propane. Have you seen that, guys? I don't know. In Chennai only, right? Yeah, actually, I don't know how it works in Bangalore. Well, now in Bangalore, but if you have seen, go to your home and go to your kitchen and see your cylinder. Somewhere it will be written propane and butane. Right? Now, what is the point there? It's all about whether they able to undergo combustion or not, is it not? Say, for example, if I take any hydrocarbon, right, and I make it react with oxygen, that is combustion, what is going to happen? I'm going to form CO2 and H2O. And this combustion reaction is going to be a very good combustion reaction. And that's the reason why we are using it as fuels. So what you have to say is that carbon and its compounds undergo good combustion. They undergo easy combustion, right? That's the reason why we are using it as fuels. Okay.
Can we say complete combustion?
Yes, they undergo complete combustion or they undergo easy combustion is also okay. Right?
Yes, sir.
Okay. Next, define a covalent bond, explain with the help of examples. I know covalent bond is formed by mutual sharing of electrons. Okay. Explain with the example. Say, for example, I'll take H2 molecule. I have one electron. This has to get duplet satisfied. This has to get duplet satisfied. So now we'll form both these electrons are shared between these two hydrogen, making a covalent bond. Like this will be able to explain. Right? Okay. What would be the electron dot structure of a molecule with sulfur, which is made up of 8 atoms of sulfur? Right? They want to know what is electron dot structure. That is a Lewis dot structure for sulfur, which is made up of 8 atoms of sulfur. So basically, we have to draw this thing for S8 is what we need to do. Okay. So now how can we do this? Right? Now sulfur has 6 valence electrons. Please understand that. Okay. Sulfur has 6 valence electrons. Definitely, it is not going to be octet. I think this test is definitely going to be out of syllabus for you. Right? But don't worry about it. But we'll still be able to draw it. Okay. Right. So we have
actually there in our textbook.
It is there in your textbook. And then it's good. Then it's okay. This question is there. Okay. Right. What be the electron dot structure of a molecule of sulfur made up of 8 atoms of sulfur? Okay. Anyways, no issues. Okay. So we have to put 8 atoms. Let us put the electrons first. 6 valence electrons are there. 1, 2, 3, 4, 5, 6. There are 6 valence electrons for each sulfur. Okay. Now we have to make sure that each of the sulfur atom is going to have octet configuration. So if I write 8 sulfurs, 1, 2, 3, 4, 5, 6, 7, 8. Okay. So in that case, this is also going to have 6 electrons. Everything is going to have 6 electrons. So if that's the case, this requires 2 more electrons to satisfy its octet. This requires 2 more electrons to satisfy its octet, and these two will mark a double bond. That's okay. Now all the others are also having 2 more, right? And I think that's going to be very simple, right? You have 2 more. right? I think everywhere you are going to just take up these 2 electrons and these 2 electrons like this. Everywhere you will take up the next atoms is 2 electrons is what we will take. And very simply you can draw. Remember that each of the sulfur atom requires 2 more electrons to satisfy its octet. So from each sulfur, 2 electrons are taken. Like that, they'll be able to pair up. Easy only. Okay. Right. Next. This is physics. Physics. What are the common defects? Okay, eyeglasses. Okay. Mendel observation. Explain the properties of soap in the industry. Okay. Now that's very simple, right? So we have to go for your vegetable oils. Right? Your vegetable oils are nothing but your fatty acids. They are going to contain this RCOOH, right? Now that we will make it react with NaOH, okay? And we will form your RCOO minus Na plus, right? Now this, we will make them react with your alcohols to form your esters, right? And this esters are going to be your soaps. And that's very simple, right? Next. Why is common salt added to the preparation of soap? Why is common salt added during the preparation of soap? I think to increase the concentration of Na plus. We're also talking about Na plus, right? So if I have NaCl, that is also going to contain Na plus, right? So that is why we are using this NaCl. Okay. Why is soap not suitable for washing clothes when hard? This thing is hard. So obviously your foam will not form, or say we can say that the lather won't form, and it is going to be very bad cleansing agent. That's the reason, right? All right. Next. Okay. 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 This is again physics. This is also physics. That's it. Yeah. That's
Yes.
it. Okay. Right, people. Thank you so much. We'll again meet next class.
Thank you, sir.
Thank you, sir.